today. So I want to do that now, okay? And the last thing that we ended up doing yesterday was graphing a line, and then based on that line, we wound up writing the equation of the line. So I want to go back to that. Now, what is the general equation of a line, that general format? Jano? Good. Y equals mx plus b. Now, as soon as we're aware about y is equal to mx plus b, anytime I ask you to write the equation of a line, you should be saying to yourself, okay, I need to find m and I need to find b. So, sometimes that's really easy, and one of the techniques that you can use to do that is to literally graph a line. Now, these are the last two questions from your lesson yesterday, if you're wondering where I came with them from. I think you can watch. I don't think you need to necessarily copy them. So, if the general equation of a line is y equals mx plus b, I'm looking to figure out the slope, and I'm looking to figure out the y-intercept. As I look at this, I'm going up 1 over 1, up 1 over 1, so the slope is 1, so it's y equals x. Now, I could write the 1 in front of the x, it's not necessary, it's kind of tacky, not stylish, but you could do it if you wanted to. Y equals x, and then the y-intercept is where it touches the y-axis, and this is at positive 3, so I put y equals x plus 3. Just one place where I personally have seen kids screw up in the past, and I want to make sure that I emphasize this to you right now, so AJ, head in the game. Some kids put down what would be the x-intercept here. They would see that it crosses the x-intercept at negative 3, and then they put a negative 3. It's not called the x-intercept. B is called the y-intercept. Yes?
I was just confused on the homework because at times it would say like find the equation of the line, then the
Yeah,
next question
after this I have the
is
homework
y
answers,
equals x.
so we'll get to it, okay? Promise. God bless. All right, so this technique is a very good technique. It is not a bad technique at all. And to me, what's so easy about it is if you understand that the y-intercept is where you cross the y-axis and you can count the slope up, over, rise, over, run, then you're gonna nail it every single time. It's so simple. But, and you must have sensed the but was coming there. It's like my dad. Growing up, my mom would slave over the stove, and she would cook dinner, and she would sit the family down. Now, not every night because we had things to do some nights, but when the family would sit down, my dad, he'd come to the table with a wife beater on all the time, and he would sit down, and at the end of the meal, he'd kind of push the chair back and go, you know, hon, that was a great dinner, but. And one day I just lost it. I go, why do you have to say but? Can't you just say it's a nice dinner? Now, I have been married 30 years today. And I promise you, many, many times I have gotten a dinner that I did not find particularly palatable. And I smiled and said, that's a good dinner. Because that's just the way you do things in this world.
Wait, today's your anniversary?
What?
You said you married.
Yes, today is the anniversary.
I just don't
All
remember.
right. Thank you,
Happy
thank you,
anniversary.
thank you. Thank you. Okay, so, I mentioned that this is a great way to do the problem, but. This is but. What's the y-intercept? Perfectly said. The truth of the matter is that you can't tell for sure from the graph. Go ahead.
5.
5.
5?
No.
2.
Oh, I thought it was 4. Don't you have 5?
All right, see? 5, 4.
3.
The truth is,
1.
4.2.
hi. The truth is, no one knows. And there are limitations to the technique where you graph it and see where it crosses the y-axis. First limitation is if you're going to graph it and see where it crosses the y-axis, you really should have a very much a straight edge. Now you can fold up a piece of paper, use the edge of your binder or whatever, but you want to be very exact. The second problem with it is that you don't always go through an exact coordinate point. Sometimes it's in the middle. And when it's in the middle, you could guess. Like if the slope was a half, you're probably going to go through 0.5 or what, 4.5, 5.5. But if it's like 2/7, That's not good. That's gonna get really ugly really fast. So, the whole point here is to say we need another way to do it. And I'll get into that in a couple. Okay. We computed the slope, this was 1. The slope here is down 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So this slope would be negative 5, 6. And I know my equation would be y equals negative 5, 6, x plus b. The problem is I don't know what b is, all right? And it might be a third, it might be a sixth, it might be 2 6. We really don't know. And I'll show you how to do that in just a couple of minutes. Okay. Okay, so here we have, what is the equation of a line connecting negative 1, 4, and 1, 7? And this, I am now going to show you what we would call the analytic way to write the equation of a line. And unfortunately, we lost a little bit of time yesterday. I'm gonna do one today, I'll do one tomorrow, hopefully by the third day from now, Thursday or so. You should be in good shape, but if you go home and it's a little fuzzy tonight, watch this on the internet, go through your notes again. This is not something easy to catch on to after one example. Okay, so what's the equation of a line connecting negative 1, 4 and 1, 7? Look, when I want to write the equation of a line, I immediately start thinking y equals mx plus b. All right? That should be self-evident. That should not be difficult. And oftentimes, we want to graph it and just see where it crosses the y-axis and then count the slope. If I can do that, this is a very simple question. The problem is, what if it doesn't go through a perfect point? Or what if they gave you directions and said, write the equation of the line, solve it analytically? They might use the word algebraically, even though it's technically analytically. Do not graph. How are you going to do it now? This is the answer to that. Okay, so I need to fill in for m, and I need to fill in for b. Fill in for b, fill in for m. I know the y equals and the x are all going to stay the same. So I can find the slope easy. That's not a problem. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. There's my formula set up. I don't care which point's which. You can have either point be point 1 or point 2. In time you don't write this on top of it, but for now I'm going to do it just to emphasize. When people see this y sub 2 stuff, they often get a little bit intimidated. Don't get intimidated. What this is the y from the second point minus the y from the first point. So it's 7 minus 4. Over the x from the second point, 1, minus the y from the second, negative 1. And this works out to be 3 over 2. So far, I know my answer is y equals 3 halves x plus b. Now we have a problem. At this point, there is no obvious way to find b. So some kids would say, I'm stuck, I can't do this. And then they'd want to pick up their toys and go home. The problem is, or the subtlety is, that there is a way to find b. When we write the coordinates of a point, this is always what and what? X and y. So in other words, x, y. So I can plug the 7 in for y, and the 3 halves in for x, and then solve for b. Okay? So that's the slick part of this. The slick part of this is to recognize, and both points will work the same. Recognize that any point gives you your x and your y that you need to plug into this equation. And once you do that, you get 7 equals, I'm going to change this to 1.5 plus b, subtracting 1.5 or 1.5, whatever you want to call it. I get 5.5 equals b. And then I go back up in here and I plug it in and I get y equals 3 halves x plus 5.5. And that's my correct answer. Yes?
Wait, so you would plug in the coordinate of the second?
No, either one. You get the same answer.
Oh.
The process, for those who like a summary here and want to take notes, the first thing you always do, you're given the 2 points, find the slope. After you find the slope, start writing the formula. And at this point, you think you're stuck. And it's at this point that you have to remember, either one of the points I started with give me an x and a y. So I have to put the x and the y into that equation, and that will give me the b. And then just rewrite it plugging in m and b, because you've now found both of them. Okay? Yes?
So you said it works with the other points too?
Yes, it would give you the same exact answer. Okay? Any other questions? All right. So to me, this is one of the harder things we do in this unit for sure. And you know, on a scale of 1 to 10, I'd say this is like a 7 or an 8 in terms of difficulty. So it's certainly not easy, but if you practice it a few times, it gets easy. I would strongly suggest when you see the one like this on tonight's homework, I think we're going to get to 1 or 2 during class also. I would strongly suggest that you do it, arrive at a correct answer, and if you don't arrive at the correct answer, that you go back, watch the video, and see how to do things step by step. I think it's extremely important. God bless. Okay, now, next part of the homework, you can just look and compare your answers. Thank you. Yeah. That one on the lower left corner, there's actually no answer because it says one and the other, and the graphs never overlap, so there's not an answer. Okay? Next sheet. Bless you. Come on, Sari, let's go. Question, Janelle?
Yeah, how did you, I got 9n squared, for the first number and number 3.
Well, did you work from the innermost parenthesis out? Did you get to the point where you had a -2 in front of that parenthesis and then -3n squared minus 9n plus 5?
Negative 3n squared?
Yeah, because if you notice, that inner parenthesis is -3 times n squared, which would give you the -3n squared.
Oh, I forgot to move the negative.
Okay. All right, any other questions? AJ?
X 12n squared plus 43n.
15 plus 6 is 15n squared minus 3n squared. -2 times -3 is plus 6n squared. That's 21n squared. All right. Here's the one on the bottom. Or the 2 on the bottom. Okay, by now number 6 should be really straightforward. All right, you should look at a question like that like it's easy pickings.
Wait, what?
Okay. Questions? Yes?
What are those things that you have 7, comma, and 20?
7 and 20 are the lengths of the sides.
Oh. Okay.
W works out to be
Yeah.
7 and the other one's 20. Yes?
I was
So on the test, the number 7, there was a question on similar to that.
Uh-huh.
I wrote 90 degrees,
Yeah, that was right.
but you marked it wrong.
I'd have to see. You show it to me after class. Okay. Now, let's look at this one here. I didn't do the first one. I was short of time. Here's a nice example of graph the points, and then it takes you through the possible questions. The first one is, what's the slope? You might have written -9/3. That reduces to -3/1. Could have also written -6/2, anything equal to it. By looking at the graph of the line connecting the 2 points, what's the equation? Y equals -3x minus 2. And now, I'm going to go through a second example of writing the equation the analytic way, using y equals mx plus b. Okay? So, everybody, what's the equation of a line, general equation? Y equals mx plus b. And in order to figure out the answer to this question, I need to find m and b. Now, I'm going to pretend that I don't have a graph, because part C says to solve analytically. To find the slope, I have the point -2, 4, and the point 1, -5. So my slope is y from second minus y from first over x from second minus x from first. So this is my I like to subtract in the order that the y's come out positive. You do not need to, it will work the same either way, but I'd rather do 4 minus -5.
Or plus 5.
And then -2, right, -2 minus 1. So that works out to be 9 over -3, which is -3. So now I come up here, having found what my slope is, and I write y equals -3x plus b. Now, we can look at this and see that it crosses at -2. So I know it should work out to be -2. Sorry, you're frustrating me today. Do you want to know why? Because many times other kids are doing other things and you're holding little conversations with them. And it not only distracts me, but it distracts them, and that's not cool. Now, the minute I see this, I'm tempted to get stuck. Because I say to myself, I've got one equation and I don't know what y is, and I don't know what x is, and I don't know what b is. And when I have an equation with 3 unknowns, I can't just come up with a numerical answer or a value. But then I remember that in both of these points, there's an x and a y. So I could choose either one. I'm going to choose the first one this time. Last time I did the second. It makes no difference. The y is 4, so 4 equals -3 times -2 plus b. 4 equals 6 plus b. Minusing the 6, I get -2 is b, and then I rewrite y equals -3x minus 2. And if you notice, that gives me the same exact answer that I got by looking at the graph. Now, I want to emphasize, if you can possibly draw the graph, and you get to go, you use a great straight edge, you go exactly through the point, that's a very powerful, easy technique to get the correct answer. But you will not always go through an exact point, then you have to use this technique I just did in blue and green, and you will not always be allowed to graph it. There will be some times where they say solve it analytically, and you have to do it analytically. Okay? Questions?
Can we please do number 8? Like, cause I was really confused on that.
The one at the top?
Yeah.
Not now. I want to get on to today's lesson, so I don't end a little bit short. Usually they're on multiple days in a row, so I will try to do it for tomorrow, okay? All right, school, come on, open up. Right? All right, so today's lesson's what, 8 or 9? Hopefully I have it here.
It is.
This is 8. All right, so all right, I'm going to go through this question, the first one, pretty quickly, and then I will work through the next 2 questions with you, and we'll see how we do. All right, as far as drawing a picture goes, draw a picture. Oh, I want you to do the distributive property. All right, well, look, this has 3 sides. If it has 3 sides, it has to be 3 dimensions. X plus 3, y plus 1, x plus 2.
That's kind of what I drew.
I just went through 3
The problem with drawing a triangle is it talks about the distributive property. The distributive property knocks out perimeter, because you're multiplying. Yeah, but
Oh,
there's only going to be a base times the height divided by 2, and you need to use all 3 of them. Okay, next up, I'm going to ignore the last term for a minute and just double distribute here. So that's going to give me xy plus x plus 3y plus 3. And none of that can be combined. So then I have to multiply that by x plus 2.
I don't like candy combined.
Well, none of it can be combined because there's no like terms there. Xy times x is x squared y. Xy times 2 is plus 2xy. X times x is plus x squared. X times 2 is 2x. 3y times x is 3xy. 3y times 2 is 6y. 3 times x is 3x. And 3 times 2 is 6.
Oh my god.
Now,
Wait a
these
minute,
two
I
can
should
be,
write that
hey,
down.
shh, stop. These two can be combined, so that gives me 5xy's positive.
Oh my god.
I don't see anything else here that's combinable. So, I'm gonna get an x squared plus an x squared y, that takes care of those two, plus a 3xy, oh no, I did that already, I take that back, get rid of that, I use that, plus a 2x, plus a 6y. Alright, so all I do is write them all out.
Plus 6.
Right, oh, I'm sorry, plus 6 again, thank you, Spencer. Okay, any other questions? Guys, don't go too nuts about copying the right answer down. Be much more focused on how you get the right answer. So, if I had gotten this wrong, the first mistake I would look for is what Janelle spoke of before, where she went with a triangle, and she was thinking 3 sides, but that lends itself to perimeter, and because they're being multiplied here, it's really an area problem. And the only thing that has 3 things being multiplied for area is not perimeter, it's volume. And then I need 3 sides, which would be something akin to a prism, okay? All right, so now we get to number 2. And the cool thing about number 2 is it looks to me to be another example of what we did yesterday. Today's lesson is the same as yesterday. So, it's a good day for this. -2, 7. -2, 2, 4, 6, 7. 1, 1. And 3, 1. All right, looks to me like the slope is going to be down 2 over 1. Okay? What's the slope of the line connecting them? Down 2 over 1, down 2 over 1, down 2 over 1. So the slope is -2 or -2 over 1. By looking at the graph, what's the equation of the line? Y equals -2x. Let me see here. 2, 2, plus 3. Okay? But then I think the next step says to do it analytically.
Oh my god.
Does it?
Yes.
Right? Okay, good.
But what's the difference? You still get the same.
This is great. Well, again, like I said before, they will on the Regents say to you sometimes you must do it analytically. So if you don't learn this technique, it won't be there. But the other thing is, if it did not go through a perfect point like this one, and it went through, say, the middle right here, you don't know if that's a half or 0.6. So you need the formula to be able to determine it for those. All right, so let's talk how to get through this together. It wants the equation of a line, so what do we always start with?
Y equals.
Y equals mx plus b.
MX plus B.
Good. Now, the next thing we need to do is we need to find m and b. How do I find m? Everybody.
Y spelled
Put
like-
1.
Slope formula, good. Y from second minus y from first over x from second minus x from first.
Couldn't you just use 1?
What?
They give you the point 1, 1, so couldn't you just use 1 for both of them?
But you need both for slope.
We're finding slope right now.
Well, yeah, but we already know this one.
Oh.
Yeah, but this said do it analytically.
Oh my
When we're
God.
doing it analytically, we don't want to look at the graph.
That's a lot of unnecessary work.
Didn't we just say you need to know both techniques in case it doesn't go through a perfect point?
Yeah.
Or in case they say you do it analytically. So it is necessary. It might be annoying. Now, the slope is going to be, the y from the second is 1 minus the y from the first, 7. The x from the second, 1, -2 there, which is going to be -6 over 3, which is -2. What do I now do with the slope now that I know it? Everybody,
Add it in.
You,
put it in. Good. Okay, so, next step. Y equals -2x plus b. Here is the step where you get stuck or you finish it out. What do I do at this point in time?
oh my god.
AJ,
Take any point and
Right, substitute from either point. So I'll use the first point. 7 equals -2 times -2 plus b. 7 equals 4 plus b. B is 3, and that gives me y equals -2x plus 3. Okay, the rest of today's lesson was identical to what we already covered today, what we covered yesterday, and what we just covered on the Do It. So now I'm confident you're caught up in where you should be. Yesterday I thought we didn't get enough done. Today we got it all covered. So, do a great job on tonight's homework. We'll give you the answer tomorrow, and hopefully you're in really good shape. Spencer, lights please.